All right, so welcome back to those of you who have been here before, and welcome to those of you who have not been here yet. I really just want to take a couple moments to thank you for coming. This workshop is really going to help you to guide you in helping to review math tests that you have gotten back, and maybe they haven't done great, or maybe they did good and you only missed a couple, and you still want to go over those concepts. And this is going to help you to prepare for future tests and the big goal at the end of the year, the SOL. All of these are going to build up mastering all our different math standards, and hopefully, like I said last time, it's going to help you and your student to recognize different mistakes they're making, hopefully so they won't make that in the future. Feel free to take notes and follow along. I printed it a little bit differently this week, so you have a little bit more room to write, and those slides are a little bit bigger, so you can see it a little bit better. This presentation is available on my website. It's already up there. In future, if you want to bring like an iPad or a tablet so you can follow along on your tablet rather than paper, I'm completely okay with that. And if, like I said last time, we are going over more general concepts than and test questions rather than your specific child. So if you have any questions about your child, send me an email later. I am going to do my best to keep this under an hour like last time. The math one is going to be a little bit more involved because I'm going to be modeling things. We're going to be trying different techniques. So I apologize in advance if it goes a little bit over an hour, but I will try to keep it to an hour. Like I started last time, I told you I'm working on a master's program. And one of the things that I've been working on is parental involvement and the effects on achievement. This weekend, I was working on a 30-page paper about that specific concept, and some of the literature I found said that there's not as much literature on math achievement and reading achievement, versus reading achievement. And one thing that I found that I thought was very interesting was a lot of how the parents feel about math and their abilities about math, and kind of what just like I said, that they might do math a little different ways, causes a lot of issues and stress for children. So that's kind of what the purpose of this night is. You might know how to do math. Well, I mean, I'm sure you know how to do math. And your child knows how to do math, and I know how to do math. We might be doing it all different ways, but this will kind of get us all on the same page. Not saying that your way is wrong or my way is better, but it's kind of just going to get us all on the same page. So the first thing that we're going to be talking about throughout is word problems. And the word problems are kind of the bane of the fourth grade's existence. It is important to know that the word problems on the SOL are written to kind of test the students on how well they can read and decode those word problems. And unfortunately, you can kind of think of it as sometimes they kind of trick the students. Our tests that Mrs. Burke, Ms. Williams, and Mrs. Falkenstein, we'll make our tests are worded accordingly to try to get those students ready for that. Some of the word problems are single step, where they would have to just do one computation, and other word problems are multi-step, where they're going to have to do two different operations. The biggest mistakes that I have found are students choosing the wrong operation. So that's maybe it's a division problem and they choose multiplication, or vice versa, or they don't do the problem fully. What I mean by that is they either do a single step problem when it's a multi-step problem, or they don't check their work to make sure that it's completely correct. So as we go throughout, I'm going to talk about this concept, how we do it, give examples, and then also give examples of word problems. So the word problems are going to kind of be mixed in throughout. So the first thing we're going to talk about is multiplication, which we have done that unit, but it's going to keep continuing throughout the whole year. So in this classroom, we do multiplication two different ways. One is the traditional method, which I'm sure all of you are familiar with. That is most likely the way you were taught. That's how I was taught when I was in elementary school. And most likely that's how we're most comfortable with. The other way that we do is called lattice box, which I'm sure you have heard of, and you might not quite understand this, but we're going to by the end of the evening. This is a way that I first learned when I was working my undergraduate degree, and it's generally easier for a lot of the students I found. They prefer lattice box over traditional, and as we talk about it, you'll understand why. So the first question is, why do we even bother with lattice box? You know how to do traditional, I know how to do traditional, why bother? One benefit is that it requires the students to only know their basic facts, which that's a fundamental skill. They need to know all their different basic facts for to be successful in anything. And it's going, as long as they know their basic facts, they will be able to complete a lattice box. It's going to ensure that they're multiplying every digit just the way that it's laid out, and that they're not going to miss any steps or miss anything. And it also gives the students a way to check traditional, because I always tell the students that for any operations, they need to check with the reverse. So if it's addition, they need to check the problem with subtraction. If it's subtraction, they need to check with addition. For multiplication, the fourth grade curriculum, we don't cover big enough long division problems to be able to check multiplication like this. So that's why we do lattice, because they can do traditional and they can do lattice, and the two products match, then they know most likely they're correct, unless they've made mistakes in both. So common mistakes with multiplication is right off the bat not knowing their basic facts. If they do not know their basic multiplication facts, or later on the basic division facts, they will not be able to be successful in math. That's the truth. They need to be able to do their basic multiplication facts. They need to know, you need to be able to tell them a fact, and they need to be able to give it to you right away without even thinking. This is the one thing in math that they need to just completely memorize. What good ways to practice that are flashcards, or our IXL program that we have, they have online flashcards, and that's just gonna get it ingrained in their memory. We play a flashcard game nearly every day called NASCAR in class, and it just helps the students to really develop authenticity in their basic facts. Another common mistake is rushing, and that's going to be with not just multiplication, but all math skills. For whatever reason, when we're working in class, the students take their time. They do really well. When it comes time for the test, they want to be the first one done. There's no prize for being done first, I would tell them. There's a prize for being done best, and that prize is a really good grade. Another common mistake is not checking with both methods. That the checking is to make sure that they're having the correct answer, and then not understanding what the word problem is really asking, and we're going to talk about that more later. So traditional multiplication, this is what you have grown up with. This is what I grew up with. So if they see a problem like this, they're going to set it up. It looks kind of crazy because I drew all over it. They're going to multiply all the top numbers by one place. They're going to make sure they carry over, so on and so forth. And then when they move over to the tenth place, they put in the 0 to represent that they're multiplying by tenths now, multiply by tenths, and then they add the 2 part in front. That was a quick overview. I'm going to go ahead and just model that in traditional. You are more than welcome to follow along on whiteboards. The markers are in the middle. You'll have whiteboards that you can do. So in this specific problem, it is 894 times 35.
Is that the same problem I got on my paper?
No.
No.
It is a different problem.
I'm sure you say we got a problem.
No, I made it. It's going to have a different problem. So the first thing that I tell the students is to circle the 4 and the 5, so they know they're working with those two numbers. 4 times 5 is obviously 20, so they put the 0 down here, and they carry the 2. I did not leave myself much room, so I'm just going to put everything down. So then what they do is they circle the 5 and the 9, and they know that those are the two numbers they're working with. 5 times 9 is 45. They still have this 2 up here, and a lot of times I tell them to put a plus sign there, so they remember that they need to add that in. So 9 times 5 is 45, plus 7 is 47. So they put 7 down, and they carry up the 4. So then they circle the 5 times 9, or 5 times 8, excuse me, which gives you 40, plus 4 more would get you 44. Because the 44 is on the last digit, you can just write it just like that. Then I always tell them when they move over to the 3, they need to put in a 0 here. Some teachers will put an X. Bottom line is that you need to make sure that you are now multiplying by tens, and that's why you put in that placeholder 0. We have oh yeah words, which your students might have talked about, and they talk about as teachers have a model when you get home. I'm not going to do that part of you. One of the steps is they need to remember when they move over at a 0. So we just say it like twice with like a little rhyme, and they generally speaking remember that. So now they're working with the 3. So the 3 and the 4 is 12, so the 2 goes down, the 1 goes up. I also tell those to cross them those off as they go along so they don't get confused. Then they're doing the 3 and the 9, which would give you 27, plus 1 more would be 28. Cross that off, add the plus 2, and then 3 and the 8 is 24, plus 2 is 26. Then the last thing they need to do is add this all up. So it would be 0, 9, and hopefully I matched it, and it should give you, yeah. So I did that ahead of time, so I made sure I got my writing. So that's how you do traditional method. That's the way that most likely you had done as you were growing up. That's how you most likely mostly do multiplication. realistically, the way you most likely are doing multiplications with a calculator. That's personally what I do. This is a good method. A lot of things that they mix up on is they forget to move which number they're working with. A big common mistake I see a lot is when they move over to the 3, they forget to do the 4. They just start right with the 9 because they just go right up rather than go over and then up. So that's one drawback to traditional. I know it looks messy when you draw all those circles, but I do that to prove that they have used every number. So that's traditional. For lattice box, I find this to be, for students, this is significantly easier. It's going to feel kind of weird the first time you do it because you're not quite used to it. So the first step is obviously to draw the box. I tell them count how many numbers they need and make sure there's enough boxes. Then they put the numbers on the top and on the sides. Then they put in their diagonals, and then they multiply each box up and over. And what I mean by that is they pick any box they want. And so say they want this box. So they go up until they run into a number on the top. And then they go back down and they go over. So it's 6 times 7. But if they pick this one, they go up until they run to this. They get 5, they go back down, they go over, they get 8. Again, with our multiplication oh yeah word, ask your student to model it. All these steps, all 5 steps, are completely covered in their oh yeah word. If I had a student here, I would have them do it. So ask your students. I would be more likely to do it after I have stopped. So same thing, you go up and you go over. So I'm going to go ahead and model on these. I would like for the majority of you to follow along on your whiteboard because it's going to just keep us all on the same page.
Does that mean we get over?
At the end, there will be an additional session. All right. So lattice box, it is going to be the same problem. So the first thing you do is simply draw a box. And then you're going to need 2 lines because there are going to be 3 numbers on top, and then you're going to need 1 across the middle like so. So at this point, your box should look very similar to mine. Then you're going to put the number, the first factor on top, 894. Multiplication symbol on the side at 35. So at this point, it should look like this. The biggest common mistake from this point that I see is students not putting their diagonals in correctly. I tell them to pick one box and go corner to corner and then extend. And then corner to corner, corner to corner, extend, corner to corner, corner to corner, extend, corner to corner, and extend. Some students will end up look like the X-Men logo by the end of it when we first start. So then what I tell them to do is just pick any old box. It doesn't matter to me what order they go in because this is a very visual method. It's going to ensure that they have filled in every box. So looking for a 5 on here, pick box.
9 times 5.
Okay, so not quite what I meant. Like, okay, I'll pick this box. So you pick this box and you go up, and you get the 4. You go back down, and you go over. So 4 times 3 is 12. So it would go like that because the 1 is in tens and 2. So looking for who wants me to do this. So yeah. All right, so we're going to go up to 9 back and over. So 9 times 5 is
45.
45.
Okay.
Why don't you go ahead and fill the rest of the box in yourself.
Or should I put this one? I don't know. She didn't want to do it.
I mean, I like the official one. Because, I mean, this is, when you go like this.
Well, so what you do,
Okay, you're doing like 4.
so then you pick 3. So then what you do here is you pick this box, and you go up to the 4, and then come down to the 5. So then you're missing the diagonal line there.
Right, but so that was one thing. So that was confusing to me. I mean, you still think that's
Yeah, that's why, Johnny does pretty well with this when he remembers when they're always boxes. All right, so At this point, what would go in this box? Shout out.
24.
24, correct. What would go in this box?
24.
What would go in this box?
40.
And what would go in this last box?
Oh, yeah.
Very good. So they are all filled in. Now what we do here is I say add the diagonals. So what I like to think of it is each diagonal is kind of sandwich, like slice of bread and then under, and then so 0 is all by itself, so that just comes straight down, 0. Then we have a diagonal here and a diagonal here. We do 2 plus 2 plus 5, which would give you 9.
Okay, wait a minute. If that, for some reason, let's say that would have been 10, not 9, would you carry the 1 over into the next column?
The next column is going to go over, so we'll go over that.
Okay.
All right, so then the next row of diagonals is 1 plus 7 plus 4, which gives you 12. So then you would put the 2 down there, and then you would just carry the 1 up to the next column. And I put a little plus symbol and a 1 to remember that I'm adding it into. So then again, we do 1 plus 2 plus 4 plus 7, which would give us, or I was adding up 1 plus 2 plus 4 plus 4, which would give us 11. So the 1 would go down here, and then you carry the 1. And then simply 1 plus 2.
And touch the little box. Oh, yeah.
And then that was, so 31,209.
So will this work even when we have more than 3 numbers? Like,
It will
let's
work with any number that you have. It will even work with decimals. And it will work with decimals. What you have to do, for example, if you have a decimal here, and a decimal here, this is preparing for, we don't work with multiplying with decimals in 4th grade, but they will in 5th grade. If they have a decimal there, you would draw a line here, and draw a line here until they intersect, and then you just bring it, you follow which diagonal along. That's how you would do it with decimals. We don't work with multiplying with decimals, but they
So
will.
who came up with this thing?
Mr. Laps. I have no idea. It was just taught to me in college. We weren't taught history. But
I mean, it's remarkable. I wish I had had it, but okay. We had old fashioned.
yeah, that's
Yeah.
all right. So hopefully we will have time at the end to kind of practice this more. If we need to, but we're going to move on just so I can try to stay under.
Now I know exactly what it is. Me too.
So here are some examples for a single step multiplication problem, word problem. Obviously things are not going to be underlined like this one test, but I underlined to help pull out the keywords. So if that makes 445 breath minutes per day, how many breath minutes will the factory make in 80 days? So all they have to do is very simply multiply 445 times 8. They need to underline or highlight or circle the key information to know, but they need to know that that's a multiplication problem because it's getting them an amount per 1 day. They want to know how many over 80 days. Same kind of thing in the second one. A candy store bought 17 jars of candy. Each jar has 338 pieces. How many pieces of candy are there altogether? So altogether is going to be a keyword for either addition or multiplication. In this case, it's going to be multiplication because it's getting our amount in 1 jar, and now there are 17 jars. And last thing, same concept, there are 25 bags filled with coins. There are 943 in each bag. How many coins are there? In all being another keyword that's going to show that it's multiplication. These are not where students really struggle with. And the big problem with this is when we're doing a multiplication unit test, really good because they know they're all going to be multiplication. Where they have a mistake is if we have a multiplication and division test together, they have to be able to pick the difference of the two. So those are single step problems. Second is a multi-step problem. And this is where a lot of students will make mistakes. This is for multi-step problem, which is one that came directly off one of the past tests. Hank does 25 jumping jacks 3 times a day. He does this for 80 days. How many jumping jacks has Hank done? What a lot of students will do is they will see the first 2 numbers, 25 times 3, and they'll say 75 is their answer. But that's how many jumping jacks he does in 1 day. The question is asking how many he does in 8 days. So they need to take 25 times 3 and then multiply 75 times 8. Occasionally they will come up with 25 and then 8, but very rarely will they, well, I would say very rarely. Sometimes they will miss out on multiplying all 3 numbers. They could do that in a variety of ways. They could do 3 times 8 is 24, and then times 25. But the important thing is that they're understanding that it's not asking for how many he has done in 1 day, it's asking how many he has done in 8 days.
It reverts back to reading the whole problem.
Yes, like what we were talking about on Thursday, reading the whole thing, understanding the whole thing. So second one is very similar. Mary is holding a box with 3 jars inside. Inside each jar are 12 marbles. So, and then the question is, how many marbles would be inside of 6 of these boxes? So what students will do is they'll pick up on that there's 3 jars and 12 in each, so there's 24 marbles. That's how many is in 1 box. But the question is asking how many would be in 6 boxes. So they would have to take that 36 times 6. It goes right back to what we were talking about last Thursday, reading the question fully and making sure that they're answering all parts of the questions. A lot of times, they will do part of it, they'll pick up on what they're supposed to multiply, they won't pick up on everything that they need to multiply. The next slide. Good. The next slide is the ways to practice. The iExcel website, which every student has access to in school and outside school. I know a lot of parents or students use it very frequently. I think one student over Christmas break went on for about 5 hours cumulative. We had a couple students who were well over 2 hours. Some students go on nightly. I'd like to see more students get on that if possible. But these are some other ways to practice. Topic D is going to cover all of the things with multiplication. It's going to start with the most basic, with the multiplication facts. It's going to go all the way. It's going to go through lattice. It's going to go through word problems. It's going to go through multi-step word problems. It is going to cover all the multiplication things you will possibly ever need for 4th grade. It is aligned to the Virginia Department of Education standards. So all of those things are things that they will, it might be represented slightly different than they'll see on the SOL, but they are things that they are going to need. Another easy way to practice this, make up 2 random numbers. Just tell them 2 random numbers, tell them to multiply them. They need to do it in both lattice and traditional, so they're becoming proficient in both. Another fun way that is going to be, which we do in class a lot, or we do a modified version, is you take 9 number tiles, and you can probably find these at the dollar store. You can cut up the cereal box, make them, and take a net carton, and you take the tiles and you number them 1 through 9, and you put 1, 2, 3 in the top, and then 1, 2 on the bottom. It has made a problem for you. You have them do work on a separate piece of paper, and then they can just repeatedly do this. This is one of our math stations that we do throughout the week, and they seem to like this. It makes it really easy because all you need is an egg card and 9 of these little tiles. They all do need to be single-digit numbers for it to work. In theory, you can make it 3-digit, but it's single-digit right now. Another way that will be fun for your student is to do a multiplication race. What you do here is you have a neutral third party come up with a problem and give it to you and your child. You and your child both have to solve it in both ways, traditional and lattice. They are probably, at this point at least, probably a little bit more proficient with lattice than you are. So and you're probably more proficient with traditional than you. So it's going to kind of even the playing field. It's going to make it a little competitive for them. They're going to want to beat their parents. So it's going to help them to really want to work on this. While we are done with the multiplication unit per se, it's not going to go away. We're going to continually review these skills, and they are going to see it again on benchmarks, on SOLs, and multiplication for the rest of their life. So don't let them get in the habit of thinking, oh, we're done with that unit. We don't need to do this anymore, because they do need to do this. So that's multiplication. Moving on to long division. And we just started long division. Some students started it Friday, some students started it today. So this is more of a preview of where we're going. So this will help you to really help you students study for the future. Like I was saying to the students either Friday or today, whenever we met first, was that long division, it sounds a lot scarier than it really is. Because it's not really hard. We do a 3-digit dividend, which is the number inside the house, is the way I was telling the student, by a 1-digit divisor, which is the number outside the house. We only have one method to do this, so you don't have to learn a crazy new method. We use the mnemonic, does McDonald's sell burgers raw? And that lays out our step-by-step process. And it's divide, multiply, subtract, bring down, repeat. And when I go through the model, it's simple to read. And we always tell them that they check this with multiplication because it's inverse operation and we can do multiplication, like someone had raised earlier. No matter what the quotient in the divisor is, we can make the lattice box that big. I tell them to, if they're more comfortable with lattice box, they can check the lattice box. If they're more comfortable with traditional, they can check traditional. I don't make them do the long division job and do traditional and do lattice because they would get overworked by questioning number 2. So common mistakes, again, going back to what I said at the beginning, is not knowing the basic facts. In theory, if they know their multiplication facts, they should know their division facts because they're all fact family related. They really need to be practicing their basic facts as much as possible. That being said, any parents who ever have any time that could come in and just run math facts with students, that would be great because that's one way that students can really be working in school and outside of school. It's just really going to help all the basic facts in the whole class. Really bad. Skipping a step in the process is another thing that they can mix up. And you're going to see the skipping the step in the process for probably about the next week or 2 weeks as we're working on it because it's new to them. They haven't quite mastered it. Some students are doing better than others, but overall we still need a lot of work because we've only spent 2 days on it. Putting a number in the wrong spot or forgetting to check it. Those are other things. They might put the number either it's supposed to go above the problem or below the problem. I know the one math group I was working with today had a hard time remembering where the number went. So that can happen. Or they move the number too far over. Or simply forgetting to check. Maybe they finished an answer and they forget to check them. So here's the steps that we follow for division. They're going to see a problem like this, most likely with the dividend first, and then they'll see either that division symbol or obviously the one with the line and with 2 dots, and they'll have to rewrite to this. So the first step that they do is they check if the divisor, the outside number, can go into the first digit. So can you pull, how many times can you pull 9 out of 1? None, you can't at all. So what I have the students do to practice their steps is they have to physically put a 0 here because they know they're going to do it. In this example, I just have to forget. So then what I have them do is they do 9 times 0, which is multiply and so on and so forth. I'm going to move forward a little bit. So after they've done that, now they look, eventually 14 will be down here somewhere. Now they ask themselves, how many times can I get 9 out of 14? 1. They can get it 1. So that's the divide step. So they can get 9 out of 14 1 times. So then the multiply is multiply the divisor by the number of top. So 9 times 1 is 9. They put that under the 14. Then they subtract that, and they get 5. So that would be the subtract step. Then the next step is to bring down. So they bring down the next digit. So now they have 58. So how many times can you get 9 out of 58? 6. Either you're really good at math or you just follow along. So they can get 9 out of 6, so then that's the division step. And they multiply 9 times 6, and that gets 54. Then they do the next step, which is subtract, and they get 4. If there are no numbers left in the dividend to bring down, that becomes the remainder. So then that goes up. Trying to see if I have a model here. Okay, I want to do this slide down a model. The way to check long division, the purpose is to make sure that the answer is right. This is a way that they can guarantee to themselves that it is right without asking Mr. B or using a calculator, because they need to know that's right. A lot of times when we're working in math group, students will ask, Mr. B, is this right? And I said, I don't know. You tell me. So they have to solve it themselves, and then either they realize they are right, or they made a mistake, and then they go back and they find their mistake. So the way that you do this is you multiply the divisor with the answer. What I tell them is do the number outside the house with the number on top of the house, not excluded the remainder of right hand. So they do 9 times 16, which would give you 144. And then they have to add in the remainder. So 144 plus 4 would be 148. I tell them if this number matches this number, they know they're correct. What I try to do to trick them is I'll stop at this step. And I'll say, guys, 144 doesn't match 148. And then mostly by the end of this time, they will realize that I have forgotten to add my remainder. So they need to do that. So we're going to go ahead and practice this now. Again, I'd like the majority of you to follow along here. I have a problem ready right there. All right. So the problem in this case is 875 divided by 4. So another thing that
This is gonna be a real challenge to me because we're doing it completely reverse in my country.
will be a learning experience for all of us.
The divider is inside, the big number is outside, and the square is upside down. You're doing it wrong.
Okay, so I see what you're saying. All right, what I also have them do is I have them write the little steps along the side. So divide, multiply, subtract, bring down, and repeat. I just have them write those along the sides. I also tell them that they can look at their fingers. There are 5 steps to this. They need to make sure they're using all 5 fingers.
What about that McDonald's thing?
That's just that just does the D stands for division, the N stands for multiplication, cell stands for subtraction, B stands for burger, and repeat stands for or the raw stands for repeat. All right. So then the first thing we do is we look at this number. So how many times can you pull 4 out of 8? 2. So the 2 would go on top, and then so that takes care of the division step. 4 times 2 is 8. So the 8, and then we subtract. Common mistake they will do here is they will put the 2 down here, or they'll erase their 8. They'll put the 2 down there. Again, this is the first steps. They just need to make sure that they're eventually recognized that mistake. So 2 would go up there, subtract 8. 8 minus 8 is 0. The next step is to bring down the next number. So now how many times can you pull 4 out of 7? 1. So the 1 would go on top, 4 would go down here. They would subtract that. That's our next step. 7 minus 4 is 3. What's my next step?
Bring down 5.
What do I ask myself next?
How many times?
4 will go into 35.
Right, so how many times can 4 go to 35? 8. So 32. Subtract. What happens to that 3?
The remainder.
Good. All right. Am I done with this problem?
No.
Why am I not
Check
done with this
yourself.
problem? Right. So I'm just going to erase my work. You probably might need to also. I didn't mean to erase that much. All right. All right. So I erased just so I make sure I have the number. All right. So it's 875. All right. So we do 218 times 4. And again, they can use traditional. They can use lattice box. Whatever is best for them. I recommend it. I'll do a traditional. I'll also show you lattice. One of the students, forget who, came up with a really cool way to combine lattice with the remainder, so it's all done in one step. So this would be 32. It's going to be 875 plus 3 is 875. So the way that the student did it with lattice box, so they could just do it with the whole lattice box. They drew themselves the box. 218 4. All right. So then, what would we go up and we go over? So what would be in that box? 32. Over multiplying. Then we go here and we go up and we go over.
So it'd be 4.
4.
0 and 4.
Right, 0 and 4. I want to point that out. And then over here,
0 and 8.
0 and 8. All right, so then what the student did here was, rather than adding it, they took the remainder and they put it into the ones column right off the bat. So they just added in the 3 there. So then that kind of saved them a step. I never thought of it that way, but that's a really good example of how students can teach you to do things. So that would give you 5, 7, which matches your dividend, and that matches it.
What was it? Oh, yeah.
That's something completely. All right, so that's long division in a nutshell. They're going to be working on that pretty extensively for the next couple of weeks. So examples for division. In the standard for 4th grade division, there are only single step problems that are covered rather than those multiplication where they would have to multiply things and then multiply it again. They only have to do one formal multiplier division here. So let's say Boston Trucking has $912 to pay for bridge tolls. Each toll is $6. How many tolls can each the company pay? So they have to realize that they have a set amount of money, and they have to pay it in increments, and that's how much they have. But another way will be is he made 533 pieces of peanut brittle to share with his friends. He put 9 inches in pieces, and each tin, how many tins was there and able to fill up. So that's the total. He wants to put it in a bunch of different containers. How many did he want to fill? And then Jane is building 6 birdhouses. She has 302 boards to use. She uses all the boards. How many boards will be left over? This is a very important question because it's not asking how many. It's not asking how many boards would go to each birdhouse. It's asking how many would be left over. So that's very important to clue into that they're looking. Sometimes they're going to ask for the actual answer, and sometimes they just want the remainder. And they will give both the answer and the remainder. So they need to make sure that they know what they're looking for. That's something we're going to be looking for as we're going through this unit. Other ways will say remaining, leftover, but it sometimes will be as easy as what is the remainder. They just need to make sure that they're picking up on the actual remainder. So ways to practice. This is Excel topic E, the one right after multiplications. Again, it's going to go everything from basic facts all the way to word problems and below. Another way to do this is give them 2 random numbers and have them solve it. That's going to be a really easy way because you just need to do random numbers. There's probably iPhone apps to come up with random numbers. Another way, we're good with that. For the, again, if you want to go back to your egg carton and your number tiles, you take the same, okay. So you take the egg carton, you put 1, 2, 3, and then you put 1, that space is just to represent where the division symbol would go, and then it's made a problem for them. Super easy, pretty cheap. You can keep this in a car, and they can do it at any point. You just go get up their egg carton, especially after a while, and they say, Dad, are we there yet? Mom, are we there yet? Tell them to get their egg carton out, and they can practice. So those are some ways. You could also do the same race type thing here. There aren't 2 methods, so I don't know how well that would work. But also, you could always do the race thing. So that kind of concludes long division. Next thing we're going to do is elapsed time. And when we were teaching elapsed time, the standard says that they need to find from a start time to an end time and how long it was in between. I took my class a little bit further than that because I feel that it is important for them to know if something started and lasted a certain time or it was ended here and it lasted that long. It's kind of an important skill to know. I mean, elapsed time is going to be one of the biggest skills that's going to impact. This was a very hard skill because of the way that our number system is set up. Our numbers are based in base 10 versus time is going to be based in base 60. So if they're trying to do straight subtraction, they need to make sure that it's a 24-hour clock, or they need to borrow 60 minutes from the hour, and it gets kind of confusing, which is why we had 3 different ways that kind of tried to avoid that. Occasionally, they will need to find the elapsed time. That's what they're going to see most on the SOL and the benchmark and that kind of stuff. Start time or end time. We're going to use 3 different methods depending on what they're going to need to find. The one that they're going to use most commonly is going to be the timeline method. And you might see timeline method, how I do it, slightly different than how other teachers do it, but the same basic kind of concept. And count back and count down. And whereas you and I can kind of look at a clock and kind of just figure it out with our minds, the students at this level aren't quite, their brains aren't quite to that level where they can do that as easily. They will sometimes get close, but they might not get it completely exact. So common mistakes are not knowing how to read a clock or not knowing what different clock things are. On IXL, one problem I find is some of the problems will say it is 20 to 8. How long is it going to be till 9, quarter after 9? Some students at this point don't know what 20 to 8 or quarter after the 9 means. That's something that should have been covered in prior years. We do touch on that briefly, but we're more on the computation part. So or not physically not knowing how to look at one of those kind of clocks. I mean, a lot of students use digital clocks; they see them all the time. So that's kind of how technology is going. They still need to know how to read that kind of clock. Not choosing the correct information or method, falling for distracting the information, or trying to count back when they're supposed to count up, or count up when they're trying to count back, or using count up when they're trying to do timeline, that kind of stuff. Not having to subtract all the information if it's a multi-step problem, Not switching over AM to 4 p.m. to PM, that's a big thing if they get class over 12. This class didn't do this as much as my past class, making sure that when they hit noon or when they hit midnight, it's now AM or PM or vice versa. Not regrouping for 60 minutes, and we'll talk about that in a moment. And not going back an hour, we're counting back minutes, and it goes over 12. That goes with the count back method. Luckily, they're not going to see that kind of stuff as much in fourth grade, but they are going to see that kind of stuff. So I felt it was a little bit important to take them a little bit beyond what the standard is. So the timeline method is used when it's a start time and an end time together. So for example, Mr. B started washing dishes at 8:45 a.m. and finished washing dishes at 12:05. How long was he washing the dishes for? And why did he let that amount of dishes pile up? That's a good question. So it gives us what time I started, what time I ended, and it's asking for the duration. So what I told them to do is draw a timeline, which looks like I tell them capital I on the side. They put the start time at the beginning and the end time at the end. Then what I tell them to do is add lines for each full hour in between. Some teachers will do this a little bit differently. They'll, rather than going to 9 o'clock, they will go to 9:45, 10:45, 11:45. This is the way that I have done with my student teaching experience, and they handle pretty well with it, so this is kind of what I roll them. I tell them that they need to put the next whole hour. I told them to what's the next o'clock after that time. So they know after 8:45, the next o'clock would be 9, 10, 11, 12. Sometimes they would write the AM and PM, sometimes they didn't. The AM and PM helps them to just make sure that they're recognizing that 12 is over. So then what I told them to do was do their minute and hour drills. So from 8:45 to 9 o'clock is 15 minutes. That's where some students struggle, is figuring out from that time to that first hour, how many minutes is that? What I told them to do is a whole hour is 60 minutes, and they already have 45 minutes, so subtract that. That kind of caused some problems, because what they would do at the end here is, this is what I call the easiest jump, because it's from a whole hour to minutes, and all you do is take the minutes. They would subtract that from 60. So it helps sometimes it's kind of throw them in a backwards direction. So when they jump to the next whole hour, then I would tell them to do all their hour jumps. Some students will do a jump for 1 hour, jump 1 hour, jump 1 hour. That works for the student. I said, great, go for it. Some students would ask if they could do all the jumps and then just write 3 hours. That's kind of what I do. I just do all the jumps. So 1, 2, 3, that would be 3 hours. And then what I always call the easiest jump, just to try to tell them that they don't need to overthink that last jump, is from 12 to 12:05. Obviously, that's only 5 minutes. They just need to take that. So then what they do is they added all of the minutes, and it's in pink, so you can't really see it very well, but they added 3 hours plus 15 minutes plus 5 minutes, which gives you 3 hours and 20 minutes. If the minutes are over 60, which I think in the example I came up with on the smart board is over 60, they need to subtract 60 minutes and give it to the hours. You can kind of see how this becomes a little bit of a complex process, because there's a lot of processes involved, but as long as they're practicing, they get pretty well at it. When I did my student teaching in 3rd grade, and using this method, we only did this method, and the students picked up on a really good. This 6th step was the hardest part, but they just need to remember to borrow that 16 move code. So in our example, I didn't do a word problem here. I just did. So the start time would be 8:18, and the end time would be 3:43. So I'd like you to follow along with me. So the first thing you're going to do is draw a timeline, which again looks like a capital I on the side. Then you would do 8:18 a.m. here, and 3:43 p.m. here. The timeline should look relatively like that. Now, what's the next o'clock that comes after 8:18?
9,
9 o'clock. And then
11,
and then
12,
and then
1,
and then
2,
and then
3,
and then
4.
right, you don't need the 4 because that's just trying to. So I just write it like that for the sake of time. It's okay to write the top and all that. So from 8:18 to 9, I would try to tell those students who would try to ballpark this. I would tell them what's from 8:18 to 9, how many minutes is that? If they couldn't tell me in 3 seconds, I said, here's how you're going to find it. So you would subtract the 60 from the, or 18 from the 60, which is 42, I think I heard. 42. So I go like that. So then they're going to do all your hour jumps. So 1, 2,
3,
6.
and you stop at the last whole hour. So you get 6 hours there. And then simply you do
43.
43. Now you need to add all of this up. So we are at 6 hours plus 43 minutes plus 42 minutes. They can do this all in one step or in multiple steps. It's just easier for me to do all at once. So we get 6 hours and 85 minutes. And I always ask them, is 6 hours and 85 minutes for real time? Technically speaking it is, but they know what I'm asking. So 6 hours and 85 minutes is not real time. So what I tell them to do is they have to take 60 minutes from the hour, or from the minutes, and get that over to the hour, because 60 minutes is 1 hour. So 7 hours and I say they're still not technically done at this point, because if you look at that in my mind, that says 7:25. So just to get them in the habit, I tell them they need to write 7 hours, 25 minutes, just so it's clear to me that I know that they're solving for a duration, not for a time, because if they just put 7:25, maybe somehow in their mind they ended up at another time. So I just have them like that. So that's basic overview of timeline. Like I said, other teachers will do, this would be 9:18, 10:18, 11:18, 12:18, 1:18, 2:18, 3:18, and then they just do one. That might be easier for some students. This is the method that we kind of got on the roll of using, so that's why we wanted that. All right, the other two things are count up method, and this is when a start time is given, like what time something started and how long it lasted. So the example is Mr. B began washing dishes at 8:45 and washing for 2 hours and 30 minutes. What time did he end? So the first thing I tell them to do is add the hours. So 8:45, 9:45, 10:45. So that's 10:45. And they cross off the hours when they're done. The second thing I have to do is add in the minutes. So 10:45 plus 30 minutes is 10:75 a.m. I asked them, is 10:75 a.m. a time? Hopefully they will say no. Then they subtract the 60 from that and get 11:15 a.m. This breaks it down into different steps for them. This is the way that they had the easiest time with, because it's simply counting up the time. The next way, the count back method, is where they struggle with most. So here, 7:43 a.m. and it lasted for 9 hours and 37 minutes. We're doing the count up method. So what I would have them do is using their fingers, or they could write it out. I would say 7:43, 8:43, 9:43.
10:43,
11:43,
12:43,
1:43, 2:43,
43,
and 4:43.
So they're now at 4:43. And what happened when we crossed over 12? Change the PM. So I cross off the hours. Then what I would have them do is add in the minutes. I have them do this as an addition count because it's easier that way. So then they get 480, and I would say, is 480 a time? Hopefully they would say no. They would subtract the 60. One common mistake I see here a lot is that they will subtract the 60 and they will go to 20 there. They'll forget to get that 60 to the hour. So they'll say 420, and I said, well, 420 is less than 480. And you were trying to go up. Does that make sense? Okay, and they fixed it. Close. So 520 there. Like I said, they're not going to see this kind of thing on the envelope, but it is kind of important to know because you might need to know timelines. So that's your point anyway. The last method, which was the most difficult method for them, and will be because of the way the number system is based, this is given when an end time and elapsed time are given. So Mr. B, I forgot to actually change the wording in that problem. It should say Mr. B ended washing dishes at 8:15 and he had washed for 2 hours and 30 minutes. When did he end? So I actually forgot to change that. So don't go up and download this thing until I change it. So we need to count back the hours. So from counting back 2 hours from 8:15 would be 6:15, like that. And then they have to count back 30 minutes. One thing I tell them to do, I tell them to draw a clock.
I got digital.
I should pick up for once. All right. So what I would tell them to do is draw themselves a clock, and they're at 6:15, and they still have to go back 30 minutes. Because if you try to take 30 minutes from 6:15, then you have to start doing that crazy thing, you have to borrow 60 minutes, and it kind of confuses them. So then they draw a clock, and they go 5, 10, 15, 20, 25, 30. So they're at 45, they have to recognize that they crossed over 12, which will bump their hour back. So getting them 5:45. Drawing the clock is basically the way we would start and end every time that we were working with elapsed time, just to get them in habit. Whether or not they did that when they were working independently is another issue. Some of them did, some of them didn't. It's just always important for them to use that. Or, I mean, they can even look at the clock. I did see a lot of students looking at the clock. Drawing the clock is going to be very, very helpful. So, quickly to model this. All right, so I had a clock here for us. So now we're counting backwards from 7:30. So counting backwards from 7:30 would be 6:30,
5:30,
4:30,
3:30, 2:30, 1:30, 12:30,
10:30.
11:30 p.m. because we crossed over midnight. So they would have to take 43 minutes. So what I would have them do is they would count back 40 minutes because you can't really, it's easier to count by 5 and then take 3 more back. So they'd be at here and they'd go 5, 10, 15, 20, 25, 30, 35, 40, and then 3 more. So that would get 47. Yes. All right, so they would be at 47, but what happened when we crossed over the 12? We had to go back 1 more hour. So 10:47 p.m. To check this, they could take that and then count forward and try to get there. Like I said, this is not something they're going to see on the SOL, most likely. It's some work for them.
All right, get the bottom of the paper right. You didn't do the one.
I made a mistake somewhere. So your homework assignment. Was it 10:50? Yeah, so that was Mr. B wasn't listening. So I'll move myself down.
Dishes again tomorrow night.
Yeah, that's what it is. I just wash dishes all the time. All right.
Anytime you want to come over, I got dishes.
Send your children to my house so they can wash my dishes.
Mr. We have a question. From last week's homework, the count back problem, where you gave the example of how to do it, and I sat there with Liam, and I think I'm really good at math, and I could not figure it out. You put two different durations that you counted back from, but it didn't show the example.
Let me see if I have an example here.
Is that something they're gonna see a lot of with the two?
Um,
Like you washed dishes for 2 hours and 50
Oh,
minutes,
I
you
know
took
what
a
you're
break
talking
for an hour and 45, and you're
well,
counting back all of that, but there was no example given really.
they're not necessarily going to see that kind of thing on the count back method. I know that they will see occasionally on the count forward method where they have to count. So what I would recommend them doing is either add those minutes at first and then put in there, or do it 2-step problems. That would be a 2-step problem. They're not going to see that as often. That was just kind of an extra challenge problem.
Okay.
Good clarification. All right, so examples for last time. Mr. Jones went golfing at 4:15 and returned at 7:15 or 7:45. How long was he gone? So that would be a timeline that's given the start time and that time. Mrs. Smith started baking at 9:16. She baked for 7 hours, 6 hours and 17 minutes. When was she done? So that's what time she started, what time, how long she was doing, and when they want to find out when she ended. So highlighting and underlining keywords are important. Mr. Johnson got home from work at 6:37 p.m. Before this, he had been traveling on Route 66 for 1 hour and 20 minutes, on Route 55 for 37 minutes. This is the kind of problem I think you were referring to, where there's 2 steps. They're not going to see this as often. They will see that at some point in their life. It's not necessarily in 4th grade, but it's just kind of get them ready for the future. And when did he leave work? So that's a count back method. Like I said, they're not going to see the multi-step as much. I just like to give them a little challenge. Just put them ahead a little bit. All right, so ways to practice ISL topic O. It's going to be all the ones about time. That's going to start with basic reading the clock all the way up to multi-step problems like what I was just showing you. So you can use your daily routine to provide scenarios for a child. So you can say, it is 3:35 p.m. You have to go to bed at 8:45, so you can be well rested for Mr. B's rural workload tomorrow. How much time do you have? So that's how much time before the example to count up would be it's 3:35 p.m. We have read for 2 hours and 35 minutes. What time will you be done? And so they have to figure that out. Our countback method is it is 8:45. You've been working on your book project for 8 hours and 30 minutes. When did you start? Okay, we go. Going back. So you can use your daily routine. Pretty straightforward. All right. And I'm almost exactly on time. So, any questions about anything? I know I covered a lot what you did in an hour, students did over a whole advisory. So you should be commended for that. If there are no questions, I am very grateful for you joining me. It is very important, like I said last time, for everybody to be on the same page. Please be sure to use these strategies with your child. It doesn't really help for you to come here and then not help your child. Just help. Whenever you have time, it's really important. Your support is really going to make the difference. We will be taking the math benchmark soon, most likely not this week, but sometime next week. They will not completely be proficient in division by then, which is okay because I use the math benchmark more of the thinking what we need to review, what we need to go forward. So that's okay. And the long division test will be coming in a few weeks. Last thing I need you to do is complete the feedback slip, which is the very last page in the START survey. You have not done that yet. There's a white basket over here. Put them in anywhere that's out. And on that START survey, one thing I want to add is there is a question, what day of the week works best for you, just so I know for planning for future. And also another question I didn't have time to type in there would be if you would like for us to use different forms of technology like Chromebooks to kind of you can follow along on. So if you have a preference for using technology or not technology, just drop that down for me.
What if we like paper? Want me to jot that down?
Yeah, that just whatever your preference is, paper or technology. I'm good with both, so I just want to know what's best for you guys. And I look forward to seeing you next time. It will both nights, both the reading and the math night, will most likely be after benchmarks when I have the data and we can kind of analyze that together. Kind of like what we did at conferences back in November. So, any last questions? I'm going to turn off the recording if there's no questions.
Oh, yeah.